Hello everyone, I'm Masoom Rabbani and I'm going to present our work result, Remote Attestation of Intermittent IoT Devices. This work is a collaboration between KU Leuven, VUB, DTU and Leiden University. In this presentation, I will first discuss about IoT security issues and brief overview of remote attestation process. Second, I will discuss our protocol reserve. Then I will discuss the working mechanism of reserve. And I will end the presentation with conclusions and future work. I will first explain how remote attestation fits in the context of IoT security and then present an overview of remote attestation paradigm. As we all know, IoT devices are low-cost, resource-constrained, tiny embedded devices that lacks sophisticated security measures. And these attacks exploited the very same vulnerabilities. So now the question is how to detect malware presence in a device which is potentially infected. One key technique that can deal with this issue is remote attestation. Remote attestation is basically a security protocol that runs between a trusted party called verifier and potentially untrusted party called prover. And the sole purpose of verifier is to verify the trustworthiness of the prover. In this slide, I will show a typical representation of remote attestation operation. Verifier and provers already shares a key. Verifies knows the legitimate state of the prover, which is basically hash digest of the untrusted software. The prover depends on trusted component on or called as a trusted execution environment to perform attestation. In step 1, verifier sends challenge in the prover. In step 2, upon receiving the challenge in, the prover perform attestation, which is basically hash operation over its untrusted software. And in step 3, the prover compute MAC on the received challenge and the hash digest and send it to the verifier. Verifier on its end also compute the attestation and with the stored legitimate expected values or H prime. And then the verifier checks the value sigma prime with the received value sigma. And if sigma and sigma prime matches, that means the prover is in legitimate state, else the prover is malicious. However effective, state-of-the-art remote attestation has some open challenges. For example, it is an uninterruptible atomic process and remote attestation is an overhead operations. Thus, remote attestation in its current form is unsuitable for intermittent IoT system. To address these issues, we propose reserve. Reserve is first remote attestation protocol designed for intermittent IoT systems, and reserve also support interruptibility in attestation process. In reserve, every IoT device is bootstrapped by the network operator during offline phase. The network operator divides the IoT software into different checkpoints. These checkpoints, on the other hand, indicates software modules. In reserve, device software follows a modular approach, and every module is a standalone software component. This is also the minimum unit for devices to perform attestation uninterruptibly. Once the attestation of a module, for example, in the picture module 1, completes, the device then sends the result to the verifier. Now I will discuss the working principle of reserve. Operation of reserve is divided into 2 rounds. First, we'll discuss round 1. At step 1, every device will perform its regular operations immediately after waking up from sleep mode. In step 2, the device will perform the hash operation. This hash operation is a self-triggered attestation process, and in this figure it shows as module 1. To guarantee freshness of the attestation process, device also include timestamp with the hash output of the module 1. In step 3, once the module attestation is finished, the device uses a pseudo-random number generator to generate a random number as shown in the figure as Ri. That indicates a line of code in module 1, and the device will securely store the line into the checkpoints. And in the figure, we have shown as a green patch on module 1. And the device stores this line of code into M1 Warwick. In step 4, the device stores the attestation result, and before going to sleep mode, it concatenates the output with the attestation result and sends to the verifier. In round 2, the first 3 operations are identical, but involves another module, as shows in the figure is module 2. To ensure that previously attested module, which is module 1, has not been compromised during offline mode, the device will check if the line saved inside M1 ORIG matches the current state of the module 1 by comparing them using Hamming distance. And again, before going to sleep mode, the device concatenates the output, the attestation result, which is in this case, the attestation result of the module 2, and the result of the Hamming distance. So the only difference of between round 1 and round 2 is step 4, which is checking the Hamming distance, and concatenation of the result of the Hamming distance with the output. And these 2 steps will follow for every other modules. And the first 3 steps will remain same for all the other modules. And then before going to sleep mode, the device will send the output to the verifier. So now the conclusion and future work for Reserve. Reserve is a lightweight and novel RA scheme, which is remote attestation scheme designed for intermittent IoT systems to allow interactability in a remote attestation process. It detects malware presence in online phase and guarantees partially software legitimacy during offline phase. Our future work involves the implementation of Reserve on real IoT system. Thank you for your kind attention.